Welcome to the Explainer. Today, we're going to decode the invisible language of the universe. It's a simple rule that explains everything from why a planet orbits the sun to why a ball falls right back to Earth. We're talking about force and motion.
I mean, really think about it for a second. What actually makes things go? You see a car start moving, a ball fly through the air, a leaf flutter down from a tree. None of them just decide to move. So what's the secret command that sets it all off? And, on the flip side, what makes them stop? The car hits the brakes, someone catches the ball, the leaf finally lands. This isn't just random chance, it's physics. And believe it or not, there's a single reason for all of it.
Now, you might think these are totally opposite questions, starting versus stopping, but they're not. They're actually controlled by the exact same principle. The answer is one single, really powerful idea.
And that idea is force. Okay, so the textbook definition is pretty straightforward. An external agent that can change a body's state of rest or motion. I know, it's a short sentence, but it might be one of the most important ideas in all of science. Let's really unpack what that means. At its very core, a force is just a fancy word for a push or a pull. Simple as that. But here's the key, the part you absolutely have to remember. It always comes from the outside. An object can't push or pull itself. This is what makes force the ultimate game changer for absolutely anything that moves. Let's just lock this idea in our heads for a second. Force is external. An object can't just decide, I think I'll start moving now. Nope, it can't push itself. Something else has to act on it from the outside. That's the fundamental rule of the game. Okay, so we've got a good handle on what a force is. Now, let's get into the fun part, what it does. We can break it down into three main effects a force can have on pretty much any object. Effect number one, and it's the most obvious one. A force starts motion. Think about a book sitting on a table. It will stay perfectly still forever until your hand, that's the external force, gives it a push. A rocket just sits there on the launch pad until that massive force from its engines thrusts it into the sky. Okay, effect number two, a force stops motion. That bike you're riding doesn't just decide to stop on its own. The force of friction from the brakes pushing against the wheels, that's what brings you to a stop. It's an external push acting against your motion. And the third big effect, a force changes an object's direction. Picture a baseball zipping towards a batter. It's moving in one straight line, but the instant that really powerful external force makes contact, bam, the ball goes screaming off in a totally new direction. You see, this all gets at a core principle of physics called inertia, and really all it means is that objects like to keep doing whatever they're already doing. A parked car wants to stay parked. A hockey puck gliding across the ice wants to keep gliding. In both cases, they will not change what they're doing, whether that's resting or moving, unless some external force comes along and makes them. The rule is exactly the same for both. So, you can see this isn't just some abstract idea from a textbook. It's like a brand new lens for looking at the world. In this final section, we'll show you how you can start to see this invisible network of forces that is constantly in action all around you. So go ahead and take a look around you right now. What's moving? What's staying perfectly still? The answer to why is always, always a force. They are literally everywhere, and now you know the secret to spotting them. And it's actually a really simple three-step process. First, just find any object that's changing its motion. Let's say a leaf falling from a tree. That's step one. Step two, ask yourself, what's pushing or pulling it? Well, something's pulling it down. And there you go. Step three, that's the force. You've spotted gravity. You've just identified the invisible agent at work. So here's the biggest takeaway from all of this. Every single change in motion tells a story about a force. A flag whipping in the wind? That's telling the story of the force of the air. A ripple spreading in a pond is telling the story of the force from a single raindrop. We'll just end with this thought. You now have the ability to see the invisible network of pushes and pulls that animates our entire world. It's kind of like a new superpower. So, with this new lens, what are you going to notice first?